Welcome to this afternoon seminar. The title of today's talk is Setting Up a Central Facility, and our guest speaker is Professor John David of Semiconductor Materials and Devices from the University of Sheffield. I'll give you a minute to introduce the speaker. He's been working in the areas of implementations in 3-5 semiconductors in Sheffield since 1985, and he joins Marconi, now it's known as Hukum Technology, in 2001, and then returned to the faculty as a faculty member in Sheffield in 2002 September. And between July 2002 and June 2004, he was IEEE Lyon's distinguished lecturer. He giving a presentation on the topics of low noise avalanche diodes. Professor John had published more than 190 journal papers and have presented more than 200 conference papers, mainly in the area of 3-5 categorization, synchronization, also avalanche of the diodes. Today he will share with us about the experience from Sheffield, how they set up this center facility. The center serves all the university in UK to provide the 3-5 devices for their research. Let's welcome Dr. John.
Use this mic. Okay, get this right. I think everyone should be able to hear me. Right, my talk today is not primarily going to be technical in nature. I'm going to be talking about setting up a central facility, and what the central facility is will become clear as I get past the first couple of slides. Now, where is the National Center, the central facility, which we call the National Center for 3-5 Technologies? Well, it's based about 200 miles north of London, so it's a good sort of 2-hour train journey from London to get there. And it's been going now for the best part of 30 years. And its mission is to actually provide complicated 3-5 semiconductor structures and devices to the UK academic community. Now, the capability that we have is given there. We have 2 MBE machines, 3 MOVP reactors, some device fabrication and characterization tools. The staff, we have a sort of semi-permanent staff of about 10 scientists and 6 technicians, very few of whom have anything to do with students and teaching. They concentrate just on the research. And the output is of the order of about 850 to 1,000 wafers a year. And we cover a wide range of materials and devices. So, we cover lasers, LEDs, resonant cavity devices, modulators, avalanche photodiodes, quantum dot structures, and so on. Now, so what is this central facility? A central facility is a grouping of expensive, large hardware and or software whose use is available at modest cost or free to the eligible users. This now is not just the equipment that is available, it comes with the associated manpower so that it allows people, scientists, engineers who have ideas to try things out very quickly and rapidly. The Sheffield Central Facility, of course, is concentrating on 3-5 semiconductor materials, but there are others as well, such as Diamond, which is the synchrotron light source, ISIS, which is the pulse neutron muon source, the Rutherford Appleton Labs, the Central Laser Facility, the Ion Beam Center, and there are half a dozen others offering services as diverse as computational technologies and also transmission electron microscopy techniques. All of these are things that are extremely expensive for one university to own and to run for any great length of time without considerable resources. So what is the National Center for 3-5 Technologies? What it does is it provides the UK academic community with highly characterized 3-5 semiconductor materials and devices And most of these will be unusual materials, designs and configurations which you cannot readily get from other commercial foundries or from other laboratories. So what it does is it enables academic institutions to undertake high-quality research into the 3-5 materials and devices. It should not be used to undertake research in itself. So the aim is to go out and engage with the wider community. So for those of you who are unsure as to what 3-5 semiconductor devices are, an example is given of the materials on the top left corner. These are compounds that come from group 3 and 5 of the periodic table. And its use primarily now is to make optoelectronic devices, high-speed, high-power transistors. So for example, almost all the semiconductor lasers you will find in CD players, DVD players would come from 3-5 semiconductors, as would many of the photodiodes and lasers and modulators used in fiber optic telecommunication systems. Some of the transistors used in your mobile phones, for example, which require very high frequencies and high power, or in power amplifiers, base stations for mobile phone systems, would all be using 3-5 semiconductors. So there's a wide range of applications for 3-5 semiconductors. It's easier to say most non-silicon semiconductors will probably be 3-5 semiconductors. So now we're not trying to do simple, straightforward 3-5 materials. So what do we mean by unusual? By that we mean that material combinations where they're using somewhat unusual elements from the group 3 and 5, such as antimony, nitrogen, or where the structures are quite complicated, where you're trying to grow superlattices, where you're trying to grow quantum dots, or where there are extremely small feature sizes. So, if I said to you, how many growth central facilities are there in the UK and in Europe? Well, the answer is very simple, there are none. So, several UK institutions have multiple growth reactors. For example, Manchester has a number, as does Imperial College. And they do very well for themselves, but they are not designed and set up for routine access by external users from other academic institutions.